Did you know in just the last 30 days, robotics technology has leapt forward in ways that could transform everything from how we shop to how we explore space? Welcome back to AI Ascension, where we decode the fast-moving world of artificial intelligence, automation, and future tech. In today's episode, we're diving into the top 10 most game-changing robotics developments of April 2025. Let's jump in. First up, let's talk about Amazon's newest warehouse warrior, the Vulcan robot. Forget conveyor belts and forklifts. This next-gen bot uses force-sensing technology to stow items more intelligently and safely than ever before. Designed to replace repetitive human labor in the stowing process, Vulcan detects the precise amount of pressure needed to handle fragile items or irregular packages. What makes this a breakthrough? Vulcan isn't just faster, it's smarter. It adapts in real time, making micro-adjustments without damaging goods or misplacing inventory. Amazon claims Vulcan could reduce stowing errors by over 35% and help cut worker injury rates in half. Take a look.
So the warehouse is 2.6 million square feet. It has 2,500 full and part-time employees.
Those employees are handling 3.5 million items every week here, with a lot of help from thousands of robots. Amazon says globally, robots help with 75% of all orders.
Amazon is one of the most advanced robot users in the world. Their robot warehouses are an astonishing thing.
There's some 5,000 robotic drive units here, ferrying packages around and tall yellow bins filled with items.
Instead of a human being going to get the product from the shelf comes to the human being.
Except for some drive units, most of Amazon's robots, including Vulcan, operate behind a fence.
To make sure that everyone around them is safe.
Robotic arms like Cardinal, Robin, and the newer Sparrow have been moving items and packages around in Amazon warehouses since 2021. But those primarily rely on cameras for detection and suction for grasp.
So we give the robot a sense of touch using a sensor that measures force in all three directions.
Aaron Parnes spent 10 years developing robotics for space at NASA's Jet Propulsion Laboratory before joining Amazon in 2019. Now he leads the team that developed Vulcan. When the idea first came up, he thought it was impossible.
There was a recent PhD graduate who was trying to get the robot to stow items into the fabric pods. My first impression was, oh, how naive. The real world is going to teach this new grad that robots can't do these things.
Then the team came up with the Gripper with a special sensor and some key movement capabilities.
Like sweeping the items to one side. And I had this pivot from, this is never going to work to, oh my gosh, this is the future.
The final result, Vulcan, is a 3-part system. An employee puts an item from these yellow bins onto a conveyor, where it's picked up by the first part, a moving robotic structure called a gantry.
Which is a robot that moves horizontally and vertically. We'll take that bag of Skittles and put it into our buffer wall. It waits there until the robot makes a match. So the robot brain is looking for an opportunity where it can create enough space to put that bag of Skittles.
Next, it's picked up by this robotic round foam disc.
We affectionately call that the squash turner. So it reorients the item, kind of like it sounds. Things like books where you want the titles facing out, or things where you need to align it so that it'll fit in the space.
Finally, the item is picked up by the Gripper.
It has conveyor belts built in, and so the item feeds forward and backward. So the Gripper has a sense of force on its grasp axis as well. So we don't squeeze a bag of Skittles as strongly as we squeeze a physics textbook.
That precise amount of pressure and torque is determined by an AI-powered sensor. This is the sense of touch that until now, experts say hasn't been put into commercial use in robotics.
The other thing that's super cool here is this guy. It's an extended sort of spatula, and the force sensor, the thing that we're feeling the world, sits right behind here, right on that spatula.
This new ability to adjust pressure means Vulcan can handle up to 75% of the 1 million unique items in inventory here in Spokane. Amazon's Sparrow robotic arm can handle some 60% of items, while Robin and Cardinal only manipulate packages.
We're also using generative AI to predict how the items are going to move. So if I push on the t-shirt, is it going to compress versus if I push on the bowling ball.
Vulcan's final step, finding the perfect spot to stow the item, adds some major efficiency gains for Amazon.
One of the use cases we have for AI is predicting how much space we can make in a bin, and then taking the right item that maximizes the filling of that predicted space.
Now let's move on to the next thing, a big move from South Korea. The government has launched a national initiative called the K-Humanoid Alliance, partnering with major tech firms and universities to lead the charge in humanoid robotics. The goal? To create full-body humanoids capable of real-world jobs by 2028. That includes disaster response, elder care, and even smart factory roles. One standout model from the initiative is a bipedal humanoid designed to walk rough terrain and lift heavy objects using compliant actuation. And with funding in the billions of won, this project is Korea's boldest robotic ambition yet, and a direct response to China's recent humanoid surge. April also brought us the 2025 RBR50 list, a roundup of the world's top 50 robotics companies, selected by Robotics Business Review. This year, newcomers like Clone Robotics, Astrobot, and MagicBot made waves, joining giants like Boston Dynamics, NVIDIA, and ABB. Why does this matter? Because this list sets the tone for where venture capital and innovation are heading. And the trend is clear. AI-enhanced dexterity, humanoid design, and energy efficiency are defining the future of robots. Surgical robotics made major strides in April with next-gen systems debuting that blend computer vision, AI planning, and haptic feedback. One standout, a robotic-assisted laparoscopic tool with sub-millimeter accuracy, tested in simulated organ surgery. These systems are also integrating generative AI models that can assist in pre-op planning and even detect anomalies during surgery using real-time data from CT scans. Experts say this could reduce complication rates by over 40% in certain procedures and expand robotic surgery beyond big urban hospitals. Let's head to the fields. April saw a major boost in agricultural robotics. Companies like Nio Technologies and Blue River rolled out autonomous field robots that can plant, prune, and even laser weed crops without pesticides. But here's the kicker. These agribots are now solar-powered, making them 100% off-grid. That's a game changer for farms in developing regions or climate-vulnerable zones. Farmers using these systems report labor savings of over 60% and yield boosts of up to 20%. Collaborative robots, or cobots, are getting serious upgrades in April. New models feature tactile skin sensors, allowing them to feel when a human is nearby or even lightly tapped. One company, Franca Emica, is piloting a cobot that adapts its motion path instantly if a worker changes behavior, without any manual reprogramming. This means cobots can now work side by side with people more safely and flexibly. Industries like electronics and automotive manufacturing are already deploying these for assembly line fine-tuning. One of robotics' biggest unsolved challenges: human-like dexterity. April brought a solution, Dex5, a robotic hand by Unitree, featuring 5 fully actuated fingers with proprioception, meaning it knows its own position in space without relying on vision alone. Dex5 can thread a needle, flip a pancake, or manipulate soft objects like a sponge. This hand could become a standard in humanoid robotics and remote surgery alike. Engineers are calling it the biggest leap in robotic hands since Shadow Robotics' iconic system. NASA and private space firms have accelerated their robotics R&D, unveiling autonomous robots for satellite servicing and Mars exploration. In April, an AI-controlled crawler completed a full diagnostic sequence on a damaged solar array on a test satellite. These bots can work in zero-G, respond to environmental hazards, and even build structures on lunar surfaces. This is part of NASA's Artemis Robotics roadmap, with robotic deployment expected before the next human moon landing. Several humanoid startups unveiled their robots working in real environments, serving food, carrying luggage, or guiding passengers. Astrobot S1, for example, was spotted working at a Shanghai restaurant in April, performing tasks with grace and fluidity. With the integration of conversational AI like GPT-5 class language models, these bots can now hold full conversations and handle multi-step instructions. Experts say we're 2 to 3 years away from seeing these robots in major airports, hotels, and public service roles. And finally, no technology moves forward without questions. In April, international panels met to discuss robot rights, job displacement, and AI governance. Proposals include mandatory ethical black boxes for autonomous systems and licensing for high-risk robots, similar to pilots or surgeons. The debate is heating up. Who is responsible when an AI-controlled machine makes a mistake? And what rights, if any, should humanoid bots have as they grow in intelligence and agency? There you have it. April 2025 wasn't just another month in robotics. It may have been a turning point. Whether it's Vulcan revolutionizing warehouses or humanoids entering our daily lives, the pace of change is accelerating. If you're excited or even nervous about where this is heading, now is the time to pay attention. What was your favorite robotics development this month? Drop it in the comments below, and if you enjoyed this deep dive, don't forget to like, subscribe, and ring that bell for more future-forward content.